Mm. Okay, welcome to the discussion. And today discussion is about uh, test of significance, difference of the proportion, single proportion. We know already what is a proportion. Am I correct? Proportion means what? A fraction. Okay, right. So come to this. The statistical formula for this to test the single proportion is small p minus capital P divided by square root of capital P capital Q divided by n. What is Q here? Q is nothing but 1 minus P is equals 1 minus capital P. So discuss this about, and this is the statistics for single proposition testing of hypothesis. Okay, where the small p is the sample proposition, capital P is the population proportion, and the n the size of the sample. Okay, if all the data are given to us, then we can test whether this p or the proportion of the population is significant or not. That is what we can identify. Okay, now let us take the problem here. This problem is connected to the testing of single proportion. Okay, now what is this? Let me read this small piece of question. Alpha Hospital claims that mean death per year in the hospital is 4%. So what is this? Alpha is a hospital. That hospital claims that the mean death per year is only 4%. What is the meaning? For every 100 patients, 4 persons only is dying here in our hospital. That is what the claim. Okay, right. Now what other things are given? When the sample of 600 patients taken, out of them 36 people died every year. So the total 600 samples we are taking from the Alpha Hospital, 100 patients, and from our observation we see that 36 people die every year out of 600. Okay, this is the another data given to us, and what we must justify here is that the claim by the hospital, Alpha Hospital, can be accepted or not. I mean, the claim is that every 100 people only 4 people are dying in our hospital. That is the claim, and we have to justify the hospital claim, or we have to test the significance of the proposition of the hospital, or otherwise they can ask whether we can say that that particular sample comes from that Alpha Hospital. These are the things you have to understand. Here is some spelling mistake, I think so. Am I correct? Here some spelling mistake here. HO should come there. Am I correct? Hospital. So yes, yes, hospital, right. Now right, so what is that we have to prove here is that the hospital claim is accepted or rejected, is true or false. That's what we need to justify. Okay, Right. So what we do now? Okay, first step, what are given here? That's what is very important here. So what is P given here, what is capital P given here, what is small n here, and what is Q. All those things we have to find out first. Okay, now what are given we will take there. The size of the sample is given here, that is n equals 600. Okay, so 600 patients we are taking into account. 600 patients. Okay, then what other things are given? And small p given or not? Yes, small p also given. What is small p? That is proposed in the sample. So out of 600 patients, 36 people are dying. 36 people are dying each and every year. Okay, so that the number comes like 0.06. 0.06. This is a fraction we are getting. This is a proportion of the sample. Am I correct? Right. What about the proportion in the hospital? Capital P. The capital P given here is claims that 4% are dying each year. 4% they are dying each year. Okay, that is 4%. 4% means 4 out of 100. That is what the proportion here. Which proportion? The hospital proportion. Okay, that means what? In decimal terms we can say 0.04. so this is what the hospital proportion given to us. This is what we have to justify here. Okay, now next what we want? Q we want. Q equals 1 minus P. Q equals 1 minus P. Okay, so here 1 minus 0.04. 0.04. So what is the answer we are getting? We are getting, if you remember, okay, 0.96. 0.96. So Q value is what? 0.96. Now Q equals 0.96. 0.96. So we have got all the elements needed to calculate this. For this is what we have to calculate first. Okay, so P we know that is given as 4 by 100, that is 0.04. Capital P is 0.04, small p is 0.06, and Q 0.96, N 600. So everything given to us. Okay, very good. Now let us use this in our calculation of the test statistics afterwards. Now hypothesis, that's what very important here. Hypothesis means what? A blind statement for which we cannot give the result whether it is true or false. We have to undergo the statistical test. At last only we can say whether it is true or false. Okay, that's called what? Null hypothesis. So we assume that there is no difference in the claim by the Alpha Hospital. There is no difference claim given by the Alpha Hospital. Okay, suppose the capital P is the exact proportion of the mean death per year in the hospital. We don't know exactly what is that. Am I correct? They are giving us 0.04 or 4%, but we don't know exactly what is the birth rate there. Sorry, that's the death rate there. Am I correct? So that we are assuming as P. So if that is the P, the null hypothesis, what we assume that what they say, that is 4% death rate is equal to what we are assuming the proportion death in the hospital. Okay, so this is assumed P and this is what they are giving. So null hypothesis we are taking, therefore both of them are equal. There is no significant difference between what they give and exact value of the proportion of the whole population of the alpha hospital. So the alternative hypothesis is opposite of the null hypothesis. Opposite of null hypothesis called alternative hypothesis. Therefore the exact proportion of death in the hospital is not equal to 4%. This is null hypothesis. Okay, this is what null hypothesis. Okay, now we have to calculate the statistical value first. Now, okay, statistical value we have to calculate. That I am calculating here. There is no space, therefore I am going for here. So Z equals, now look at that, this particular formula, look at that, this particular formula. What is small p? The proportion of the sample, am I correct? So small p, what is given here? It is 0.06, 0.06 minus capital P, that means the population proportion. What is given there? 0.04. Now look at that, the population proportion is 0.04. Am I correct? Right. Now we have to divide this. We have to divide this by square root of P, that is capital P, that is the proportion of the population, the hospital, that is 0.04 multiply by what is this? Q, am I correct? So Q is what we have calculated, 0.96. So 0.96. Look at the formula here, divided by n, divided by what is n here? 600. So this is what the characteristics or test statistics for the significance difference of single proportion. To find out the significant difference of the single proportion, this is the formula we have to calculate this. Okay, so I will give you some 2 or 3 minutes. You calculate, then you tell me the value for this is set. Okay, come on, go on. Yes, thank you very much. Now the answer for this is 2.5. Answer for this is equal to 2.5. Have you got that? Okay, congratulations for that. Okay, 2.5. 2.5. Right, so the test statistic value for Z to test the significance of the single proportion we are getting as 2.5 for this given situation. Okay, so I am deleting this, and the final answer what I got, 2.5. okay, 2.5, that is what I got. So that I am going to write here 2.5. Now I get that Z is how much? Z calculated value of Z is equal to 2.5. Now next step is calculation of table values. Am I correct? Next step is what? Calculation of table values. And what is this? Is that variate? Is a normal variate. Am I correct? You come to this particular table here. So for two-tail test, 1% value is 2.58. Two-tail test for 5% level of significance, the value is 1.96. For one-tail test, 1% level is 2.33. For one-tail test, 5%, the value is 1.645. But in the question, no level is given to us. Am I correct? In which level the hypothesis, I mean null hypothesis, is accepted or rejected? That's not given here. Therefore we can give our own, and it is a two-tail test. Am I correct? Look at this. It's a two-tail test. Why? Because not equal to. Therefore two-tail test we have to follow. What I am doing, two-tail test I am taking, and 5% level of significance I am taking. The value is 1.96. So here the tabular value, here the tabular value for Z at 5% level of significance, two-tail test, the value is 1.96. So I am taking this as equation number 1 and this as equation number 2. Now I am going to compare equation number 1 and equation number 2. Okay, equation number 1 and equation number 2 I am going to compare now. So what I am seeing here is that the calculated value and the tabular value of Z, that means the test statistics, I am going to compare. Okay, so the ZC calculated value of Z is 2.5, whereas the table value is 1.96. So what I am seeing here, and this is what the sign I am seeing. Am I correct? If this is the case, what is the meaning is that H0 should be rejected. Okay, which implies H0 is rejected. H0 is rejected. Rejected. H0 is rejected. Why? I told you already that if the calculated value of Z is greater than the tabular value of the Z, then we have to reject the H0. That's what I told you. This is H0. We have to reject the H0. Okay. So we have to reject the H0. That means this we are rejecting. This is what we are rejecting. If we reject that, what is the meaning? We have to accept this. We have to accept this. Am I correct? So this is what we have to accept. So this accept means, what is this? The proportion of the hospital claim, but that is not equal to 4%. So actually what is the meaning here? Our final conclusion is that the claim by the hospital is not accepted. Okay, H1 is accepted. That means H1 P is not equal to 4%. That is accepted. That means the proportion claim by the hospital is not accepted. Therefore the the claim, we can say that the claim is not accepted. is not accepted. Right, therefore the claim is not accepted by the Alpha hospital. That's what we have to understand very clearly. Okay, so what is the thing is that in this particular problem today that we are discussing nearly 30 minutes, what is the thing is that the large samples given to us and we have to test the single proportion of the population, significance difference we have to find out. For that the data are given to us, and then the data are given to us, then we have to prove that for single proportion the test statistics formula is P minus capital P divided by square root of PQ by N, and P sample proportion, capital P population proportion, Q is equal to 1 minus P, and N is the size of the samples. Okay, alright, now we are taking one problem. Alpha hospital, it claims that for every year only 4% death going on in the hospital. For that the sample we are taking, how much? 600 patients we are taking. Out of 636 people are dying, so the sample proportion is equal to 0.06, and the hospital proportion given that we have to justify 4% by formula Q equals 1 minus P, that is 0.96. So capital Q is equal to 0.96. Now the null hypothesis we are assuming, that means this is what we assume the proportion. We don't know exactly the population proportion, so that population proportion we are taking as P, exact popular proportion we are taking as P, and that is exactly equal to the claim 4%. So this is called null hypothesis. There is no significant difference between the exact population proportion and the given claim. There is no significant difference. This is called null hypothesis. So alternative hypothesis is always opposite to null hypothesis. Okay, that's what we have to understand. So if null hypothesis is the population proportion is exactly equal to 4%, then the alternative hypothesis is population proportion is not equal to 4%. Now hypothesis over. Now we are starting to justify it. For that, first we have to calculate the test statistic. We know that test statistic for to test a single mean is this one. So we are having all the data here. We are substituting P here, we are substituting this 0.04 here, we are substituting this P value here 0.04, and then Q 0.96 divided by 600. The final answer what we are getting is the calculated value of Z is equal to 2.5. Now our duty is that to find out the table value for that. Actually here the level of significance is not given to us. Am I correct? So if that is not the case, we can take whether it is 1% level or 5% level. So I am taking here 5% level of significance. For normal critical value for 5% here, note that here it is a two-tailed test. Am I correct? Because it's not equal to, coming like that, therefore it is a two-tailed test. 5% level of significance. If I take, the value is 1.96. so tabular value of Z equals 1.96. I am taking this equation number 2 and this is equation number 1. Now comparing, I am comparing the calculated value and the calculated value of the test statistic and the calculated value of the table value I am comparing here. What I see is that the calculated value is 2.5 and the tabular value is 1.96. Therefore calculated value is greater than tabular value. If that is the case, H0 should be rejected. So H0 is rejected. That is the significant, no significant difference between P and 4% is rejected. So once it is rejected, alternative hypothesis accepted. Therefore the exact proportion of the population is completely different from the claim 4% of death in the hospital per year. So this and this, between this a big difference is there, between this a significant difference is there. Therefore the claim by the hospital that every year 4% of death taking place in this hospital is not accepted. Okay, like this we have to take the problem and we have to solve it. Okay, so thank you very much for being with me. I will come with you. I will come with another problem in another video. Okay, so this video is about single proportion. Thank you.